I want to do another one with this, factoring with the u substitution, or in our case, the n substitution. So I'm going to say n equals, and in this case, I'm going to make n equal x to the fourth, because that'll make x to the eighth equal to n squared. So now I'm going to say n squared minus 82n plus 81. So my factors, this is factorable. My factor is going to be n minus 81 and n minus 1. Now we're going to put the x to the fourth back in here. So we got the x to the fourth. I got x to the fourth minus 81, and then x to the fourth minus 1. And if you remember this from Algebra 2, these are just difference of squares, but with a 4. These both factor. This would be x squared minus 9, x squared plus 9, and then this is x squared plus 1, x squared minus 1. Order doesn't matter. I could have said minus plus there, as long as you have one of each. And then now each of these you could just solve with the square root method. So I'm going to say x squared equals 9, square root, you get x equals plus or minus 3. I wrote a 1 for some reason. And then here we have x squared equals negative 9, square root, and then we get x equals plus or minus 3i. Same thing here. This is x squared equals negative 1, square root, x equals plus or minus I. And then here, x squared equals 1, and then you get x equals plus or minus 1. So, there are 8 solutions that we needed. Now, these ones would have showed up on the calculator. You could have used synthetic division to get those out of this maybe, and then got down to something that's factorable maybe and gives you these answers. But this way actually works pretty nice, and again, it's another way to kind of practice this method, and it kind of works out really well here at the end. These are great. When you can get to this point, these are much easier to solve than kind of using the quadratic formula to get those solutions.